Good day, guys. So I'll be showing you trigonometric rules. We're just going to do just only three. We'll make them very fast. Okay? So we'll just make things very fast. So at first, I'll state the rules that we're supposed to have in trigonometry. So this is going to be grade 11. So I'll show you those trigonometric rules that we're supposed to attend to. So the first trigonometric rule we're attending to, it's going to be the sine rule. Then we will have the second trigonometric rule, which will be the cosine rule. Then from the cosine rule, we'll have the last trigonometric ratio, which is the area rule. So I'll just make sure that I simplify these very fast. I'm just going to do them here. But first, before I even go further, I just want to show you something that is going to be very simple. Before we move, let's just recap on this. We have SOHCAHTOA, right? We have SOHCAHTOA. SOHCAHTOA, it's the one that helps us with the ratios. So this is going to be sine, which is opposite over hypotenuse side, cos, which is adjacent over hypotenuse, tan, which is opposite over adjacent. This is going to be our summary. Everything that is we're going to be using here, we're just going to be taking it here. Now, the second thing that I want to show you here, how do you identify the sides in a triangle? So let's say we're given a right angled triangle, right? So this triangle is A, B, C. How do we identify the sides? So we know at all times that if we're given theta here, right? So the side that is always opposite to the 90-degree angle here is always going to be the hypotenuse side. It's always opposite to the 90-degree angle here. Then there's a side that always consists of the two angles, the one we are dealing with at that time. So this one is considered as adjacent side. Then there's also a side that is always opposite to the angle that is given in the triangle. That one is called the opposite side. Are we clear? So this is just the simple part where I want you to understand, whenever you see a triangle that is given in this manner, you know that that's your hypotenuse side, this is your adjacent, as well as this is your opposite side. Then before I break down the theorems, there's something that I'm going to show you here again, of which now it's the triangles we deal with when it comes to these theorems. So the first one, obviously this triangle here, right? This is the kind of triangle we use. So where you see A here, you're given B here, we're given C here. Now you must know how we name the sides of a triangle that looks like this one. If it can take a look, this triangle is not a right angle triangle, not unless we add another line here which is going to be perpendicular to or AC. So I want you to see now how we name the sides of a triangle. So the side that is going to be opposite to this vertex, remember vertex, it's the corner where the two edges meet and form an angle in a shape, right? So this, it's A here, right? It's angle A which is opposite to this side. Since it's opposite to this side we're going to name it small letter A for this capital letter A. So this is going to be small letter A. Then there's this side that is opposite to, there's that angle which is opposite to this side. Then this side is going to be small letter B. Then there's also another one there which is opposite to this one, which is going to be small letter C. So for now, you can simply see that our corners, we label them using uppercase letters. Then our sides, we label them using lowercase letters. Now I want us to attend to this one now, which is the sine rule. Our sine rule states that for sine A is over small letter A is going to be equals to sine B over small letter b, which is equals to sine C over small letter c. Okay, so this is what we're going to try to prove first, so that I show you where is this coming from. Now I want you to look at this kind of a triangle that we have here. Remember I said in order for us to have a right angle there, we must have a line that is drawn from A here perpendicular to this, so we'll form a 90-degree angle there. Then from there, what we are supposed to look for is the fact that here we're given sine, and another sine there. So in order for us to be able to prove sine rule, we must use the sine here first, as well as also find the sine of C there. So as you can see, this is our base angle, and this one again, it's our base angle. If we can find sine A as well as find sine C, we need to play around and check if we can be able to form something like that. Let's try and see. If we're going to say we name this side H, for example, if we name the side that we added here as H, then we're going to find sine A here. Sine A is going to be opposite over hypotenuse side from what? From our SOHCAHTOA. Then our sine A is going to be, our opposite is going to be H. And remember why we're saying that, simply because it's facing the angle that we're dealing with, which is A in this case. Then our opposite, our hypotenuse side, is the one that is going to be facing the 90-degree angle, which is going to be C. So now this is going to be C, then this is sine A here. Then now, how do we solve the H now? This H now, we're going to cross multiply, we get H as C sine A. Now from there, we are going to look for sine C now. Sine C, if we're looking for sine C now, sine C is going to be opposite again over hypotenuse side. And if it's opposite over hypotenuse side, this is going to be sine C here, which is equals to our opposite. When we're looking at this angle now, this is the angle we're focusing on. Then opposite, it's going to be the one that is opposite to the angle, which is H. So we're going to put H here over hypotenuse side is the one that is opposite to 90 degree. So we're going to put A here. So this is over 1. We cross multiply. Our H is going to be A sine C. Now I want you to look at the fact that we have A here, we have A, H again here. So H obviously is equals to H, which simply means C sine A is going to be equals to A sine C, right? So now we are trying to form something that will look like these two ratios there. So we can simply divide by AC here and also divide by AC here, so that A and A cancels, C and C cancels. Then we're left with something like sine A over small letter a, which is equals to sine C over small letter c. Now I want you to think of something. If we can take this triangle and turn it again, so we're looking for B, sine B as well as sine A, it will prove that sine B over B here is going to be equals to sine A over A. And in this case, we just proved that sine A is equals to sine C. So if we prove that sine B is going to be equals to sine A, it simply means sine A is equals to sine B, which is also equals to sine C. And then we are done proving the sine rule. I think when it comes to this one, we are done. I'm just going to follow with the second part of the cosine rule. Thank you so much. Okay, I'm back again with the second part of this lesson. So now we are attending to the cosine rule. The cosine rule, what does it state? It states that a squared is going to be equals to b squared plus c squared minus 2bc cos a, right? So we can also write that as b squared is equals to a squared plus c squared minus 2ac cos b. We can also write it as c squared is equals to a squared plus b squared minus 2ab cos c. This one might take a lot of space here. We'll try by all means to make sure that we cover everything in this small space. So now, yeah, let's attend to this one, cosine rule. So the cosine rule will require us to add something in the form of a Cartesian plane here, but we'll add it somewhere around about here. So this is going to be our Cartesian plane here. This is going to be our y. Then this line here, use also this, including this line here, we are going to make that our x-axis, right? So this, remember, it's C, this one here. We need to form coordinates and also form coordinates on that one. Our A is on the origin here. So it's still the same triangle we used for sine rule, but we are adding this Cartesian plane whereby our A and C, they are along the x-axis, and there is a line that is drawn from B which is perpendicular to the x-axis. So we'll name this B is to 0. Then we use this as xb is to yb. Right? So now this is what we have. We are trying to prove either of these, but since our A is on the origin, so we'll use the first one there. We'll try to prove the first one. How do we get to that, right? So for now, I'm still showing you how to prove the rules. Then from there, I'll make examples. How do we calculate? How do we apply these on basic problems, right? So now look at this. What we have here, we have a triangle which consists of the two triangles there. So we will try by all means now to find both sine A as well as cos A, right? So we look for sine A as well as cos A. So when we are looking for sine A, our sine A is going to be obviously opposite over hypotenuse side from the SOHCAHTOA. So it's going to be H over C there, which is, now we know that instead of H, we have this YB there, right? So instead of H, we have that YB for the coordinate of B there. Then instead of this part here, we're going to have XB here. XB from here to here. Since the X coordinate of B here, it's XB there. Now, for our sine A, we're going to have YB over C, right? Then over 1. If we are solving this YB, we will cross multiply. We get YB as C sine A. I hope you saw that. It was simple and straightforward. After we are done finding sine A, we are looking for cos A now. Cos A is going to be equals to what? Cos A is going to be adjacent over hypotenuse side. And our adjacent over hypotenuse side, we know that adjacent is this over that one, which is going to be XB now, XB over C. Then we cross multiply, since this is over 1, we cross multiply, we get XB as C cos A. Right. Now we have the coordinate of B there. The coordinate of B is going to be this C sine A as well as this C cos A. So let's write them there on top of that. Our XB is C cos A, which is 2 C sine A here, C sine A. Then those are the coordinates of B there. Now I'll have to remove this part here. I'll remove this part so that I can get more space. Once you do sine A as well as cos B, sine A as well as cos A there, then from there we're done having those coordinates of B. Now what we are supposed to do is to find the distance here. Let me show you something here on the rule. The rule says A squared here, and you can simply see here at the end it's cos A. So which simply means if we're dealing with this angle here, the side we're supposed to find is A squared. So meaning that this is the side we're supposed to find. If we are dealing with A here, the side we're dealing with is here. If we're doing this angle C, the side we must find is C. So that's how it works, cosine rule. Yeah? Now, okay, let's try this now. Since we have that, we are going to find the distance of BC. And remember the formula we use for the distance. We're going to say BC squared is equals to XB minus XC all squared plus YB minus YC all squared. Now look at this. BC squared is A, is represented as A. So we're going to follow that and put A squared here, which is equals to, this is our XB. Our XB, we said it's C cos A, so we're going to put C cos A here, minus XC. We can simply see that our XC is B here. We're going to put B squared plus. Now, YB is going to be our C sine A here, C sine A, then which is minus the 0, which is this one here. Then we have A squared here, which is going to be equal to this. We repeat the bracket twice. So this is going to be C cos A minus B as well as C cos A minus B again. Plus this one here minus 0, it's just C sine A. Going to say C sine A here all squared. Then now, what are we supposed to do? Foil here, then we distribute there. So we have A squared here, which is equals to, here we're going to multiply this and this, which is going to be C squared cos squared A. C cos A multiplied by that, it's C squared cos squared A, right? Multiplied by that, which is minus BC cos A, again minus BC cos A, then plus B squared, then plus this one is going to be C squared sine squared A. I hope you can still see it today. Now we're going to try to simplify this and group this and this one here. So we're going to have A squared, which is equals to C squared cos squared A. Then we're going to group that with that. So C squared sine squared A. Then this is minus and minus here, or we can start with this plus B squared. Then we end up with this minus 2BC cos A. Let me explain something. Why are we grouping this and this? Because we know that that one has a 6 squared that is alone. So how can we create this and this to be just 6 squared, C squared? Simply because we know that here, if we have cos squared A plus sine squared A, we can get 1, right? So we can just say A squared here, which is equals to, we take C squared as a common factor. Then this is going to be cos squared A plus sine squared A, right? Then plus B squared minus 2BC cos A. You can simply say this part here is already there. Then this one is going to give us 1. So A squared is going to be C squared into, this is 1, the identity. This one is just going to give us 1. So we're going to get minus 2BC cos A. Then you can simply see that this one, now we are done proving it, that it's the same as that. So we can just start with B squared plus C squared minus 2BC cos A. It's going to be the same as that. But this is how we just prove the cosine rule. And once you've reached this, then you know how to prove cosine rule. And it's simple and straightforward. The same triangle. We're moving to the area rule on my third video. Thank you so much. Okay, so yeah, let's continue to the third one, which is the simplest rule ever compared to the other two. So this one is very, very basic. You wanna look for an inclusion. Now look at this, how simple it is. So it's supposed to be either the area of triangle ABC, which is equals to 1 over 2. If you're looking for, this is the angle that is given. So it's going to be BC. It's going to be BC sine this angle here, which is A, right? If you are given this side here, you're going to say area of triangle ABC is equals to 1 over 2. And you are given this angle here, so it's going to be AP now. AB sine C here, sine C. Again, you may be given area of triangle ABC, which is equals to 1 over 2. So let's say now you are given B, right? You're going to say AC. So you're going to say AC sine B there, right? But how do you prove it now? Let me show you how we prove it. Firstly, we must find the height here. The height, obviously, it's going to be sine. We're going to find sine A here. We'll use A for now. Let's pretend as if this is the angle we're given. So we'll find sine A, which is equals to opposite over hypotenuse side. Opposite over hypotenuse side, then sine A is going to be our opposite. It's H over hypotenuse side, it's C. Then when we cross multiply to find H here, we're going to find H as C sine A. Right, so let's say now we have the height. Since we have the height, remember how we calculate the area now. The area of triangle ABC is going to be 1 over 2 base times height, right? So we're going to use that. So now it's going to be 1 over 2. Our base now, if we're looking at this triangle here, our base is going to be this B here. So the B is the base of the triangle. So we're just going to put B multiplied by, what is the height? The height is C sine A. So it's going to be C sine A. You can simply see at the end we get 1 over 2 BC sine A, which is this one. Understand? Then if you turn this again, you're focusing on angle B. Then at the end, it's going to give you AC. If you're focusing on C, it's going to give you AP. So this is it. We're done proving area rule. So it ends here. Then similarly, you can also prove those two the same way we just proved this one. Thank you so much. I'll show you the examples for now. Thank you.